Today we're going to be looking at solving systems of equations. What a system of equations is two or more equations with common variables. Specifically for this section, we're going to be looking at two equations with two variables. So, for example, a systems of equations might be this. 2x plus 3y equals 12. So that's one equation with two variables. And 4x minus y equals 5. So that would be two equations, both with two variables. That is a system. There are three different ways that we have to solve systems of equations. The first way is graphically. So we can graph the system. That is one way to solve. The second way to solve is by substitution. And then the last way is by elimination. In this video, we're just going to look at the first two ways, which are by graphing and also by substitution. Tomorrow we will look at elimination. So let's go ahead and look at solving a system by graphing. To do this, we have to first graph each line, or graph each equation. If you'll look at these, you notice that they are both linear functions, meaning we don't have any squared terms, so they are just straight lines. So we can graph these. We do know how. Then, after we graph each equation, the intersection is the solution. Okay, so let's go ahead and graph the first one then. We have y equals negative 3x plus 1. So here, in the first one, our slope is negative 3. Our y-intercept is 1. Okay, so if you remember from the night before, we graphed the y-intercept first, so that is up positive 1. And then our slope here is negative 3. This can also be written as negative 3 over 1. So we need to go down 3, 1, 2, 3, over positive 1. And that is the next dot on our line. So our line looks like this. Okay? And then we can extend it out this way as well. Okay, so we have our line there. And then we just need to graph the other line. So if we're going to graph the other one, our equation is y equals x minus 3. So here, our slope is 1. Okay, there's a 1 in front of that x. And our y-intercept is negative 3. Okay, so we're going to graph the y-intercept first, so that's negative 3. And then our slope is positive 1 over 1. So we'll just go up 1, over 1, and that's our point. Okay? So now we can draw out that line. And that line looks like this. Okay? So I'm going to go ahead and add arrows onto that one. Now number 2 tells us that the intersection of those two lines is our solution. And so our lines intersect at this point, which is point 1, negative 3. 1, negative 2, sorry. 1, negative 2. So that is our solution. 1, negative 2. So here we know that x equals 1 and y equals -2. So that is solving a system of equations by graphing. Graph the two lines. The coordinate where they intersect is your solution. Okay, now let's look at solving a system by substitution. By substitution, we still find an exact solution, but we use algebraic methods to solve. Okay, we use algebra. All right, so to solve a system by substitution, the first step here is to solve one equation for either x or y. Okay, it does not matter which equation you use or which variable you solve for. So you're going to look for the easiest one. So if I look at this second equation here, notice that this x doesn't have anything in front of it. So it would be really easy for me to solve that equation for x. And if I do, that equation becomes x equals 8 minus 2y. Okay, I just moved the 2y over and I isolated the x. Okay, once you do that, the second step is to substitute your new equation into the other. All right, I know that may sound confusing, so let's work through that one together. So you can see, and I'm going to label these equations 1 and 2. So you can see that we solved equation 2 for x. So now what we're going to do is we're going to take that equation, x equals 8 minus 2y, and we are going to plug it in for x in the first one. So in equation number 1, we are going to plug 8 minus 2y in for x. So we have -5 parenthesis, this is where our x is, 8 minus 2y plus 3y equals 12. Okay, and now what we can do is we can work this equation down, and now we only have one variable, so we can go ahead and solve for y. So now I have -5 times 8 is -40. -5 times -2 is positive 10y plus 3y equals 12. If I combine my y's, I get -40 plus 13y equals 12. If I add 40 to each side, I get 13y equals 52. And then if I divide both sides by 13 here, I get y equals 4. Okay, so now we already have one variable in our solution. We just need to find the other. Okay, so that's step 2. Substitute your new equation into the other one. Whatever we solve for, we substitute it into the first equation. And then our final step, step number 3, is to plug your solution into either equation. We can use either one, number 1 or 2. To solve for other variable. And that is the last step. Okay, So let's go ahead and work out step 3. Now I have already solved for y equals 4. I just need to solve for x now. So it does not matter. You can plug y equals 4 into the first one, the second one, or even the one that you solved for the variable over here. All 3 of those will give you the exact same answer. That's why it's a solution. Okay, it works for all 3 of those equations. So let's go ahead and plug it into the one where we already solved for x. But again, the other 2 would work fine as well. Okay, so don't feel like there's only one right way. You could have done it either 3. So let's go ahead and do that. We have x equals 8 minus 2. Again, we have already found y is 4. So 2 times 4. So now we have x equals 8 minus 2 times 4 is 8. So x equals 0. So now we have that our solution for that problem is 0, 4. So that is solving a system of equations by substitution. Once you get used to this way, it will probably be your favorite. Okay? Just have to practice a few problems and you will get it. Okay, now we're just going to try 2 problems. So I want you to go ahead, pause the video, try these 2 problems, work them out on a piece of paper, and then when you unpause it, I'll have the answers there. Okay, so here are the answers to those 2 problems. You can see in number 1, I just graphed the 2 lines, and then I looked for that point where the 2 lines intersected, which was 2, 3. And then on number 2, solving by substitution, I solved equation number 1 for x, and then I plugged that x into the second equation and solved for y. There I got y equals negative 5. That's just using basic algebra. And then once I got y as negative 5, I plugged that into the equation where I solved for x. Again, you can plug that y equals negative 5 into any of the equations and it will work. And then when I did that, I got x equals 2, which you will get using either of the equations. So my final solution for that one was negative 5, 2. We will work on this tomorrow, so if it's really confusing for you, that is okay. We're going to spend 2 days on systems of equations. We will learn tomorrow night about elimination.